Hi everyone. The first thing that you should have in your mind is this question is not coming from your past paper. All the past paper questions are pretty easy and there is nothing very challenging over there. So I just created a question by myself over here so that if you are able to solve this question, of course there are very high chances that from your past papers or your topicals of Modulus, you will be able to solve literally any given question. So let's get started. We are asked to solve this inequality, that is, we are trying to find the values of x such that it satisfies this given inequality. Now the condition is that a is a positive constant. That is a criteria that we need to keep in mind. So I'm going to solve this inequality, as you know, with the help of the best available approach, that is a graphical approach. So let me go ahead and first of all tell you how the graph is going to look like. Okay, so I'll just have a quick graph on the right hand side. So this is my modulus graph where I know that my y-intercept is going to be at a and x-intercept is also going to be at a. Now, how do I know this? Of course, you need to be very solid with the understanding of the graphs. So I'm going to go ahead and plot my graph and say that something like this. This is my A and this is also my A. Now, let me go ahead and plot the straight line 2x minus A. I just need to be cautious over here. The line should be more steeper as compared to the graph over here. I know that the y-intercept is minus A, so I'll just slightly stretch my graph and say that this is my minus A. And my x-intercept, that is when my y is 0, will be at A by 2. So A by 2 is somewhere over here. So my straight line is going to look something like this. It's a steeper line. And because the line is steep, I know that this line and the modulus is never going to intersect anywhere in the future. So there is only one point of solution. And now I need to identify what is the solution with the help of opening the modulus with a plus and minus sign and finding the critical values. How do I find the critical values? I convert the inequality sign to the equal to sign, open the modulus one times with a positive sign and one time with a negative sign. So in this case, when I'm opening it with a positive sign, let's see what is the answer of the x that I'm going to get over here. So the a's are simply getting cancelled out. I'll get 3x is equal to 0. So from here I can see that my x is equal to 0. Now let me open the modulus with the help of negative sign. So it will become a minus x this time. I'll write or in between. I'll write or in between and then write a minus x is equal to 2x minus a. And this time it will become 2a is equal to 3x. From here we can see that x is equals to 2a over 3. So clearly x equal to 0 is not what we are looking into. This has to be 2a by 3. You can also confirm it using your calculator. I know that this is my 0.5a. So this value, what is 2 by 3? It has to be greater than 0.5 and smaller than 1. Let me check it. So if I do 2 by 3, this value comes out as 0.66. So of course, clearly we can see that this is the value that we are looking for on the graph. I'm just going to highlight that part on my graph that this value over here is 2a by 3. Now, I just need to look that either to the right side of 2a by 3 or maybe to the left side of 2a by 3, on which side my line is going to have greater y value as compared to the modulus. So if I look onto the right hand side of 2a by 3, I can clearly see at any given x value, my y value on the line is always greater than the modulus graph. I can also say this over here. My y value on the line is greater as compared to the modulus. What is happening at 2a by 3? At 2a by 3, both the y values are equal. So what is the inequality sign that I'm going to place? I'm going to say that my final solution over here is going to be x greater than 2a by 3. Because all the values on the x-axis that are greater than 2a by 3, I can clearly see my line is always above the modulus. What happens on the left hand side of 2a by 3? Let's see if I'll talk about this value of x. So for this, clearly the y value for the line is smaller as compared to the value of y on the modulus. So clearly my answer does not lie on the left hand side. And that is why this is my final solution. So this is what I was talking about, that if you are someone who is having a habit of sketching the graphs of modulus, you will never have any issues with respect to any questions that is involving modulus in your P3 mathematics. Now let me help you confirm visually what does this conclusion mean with the help of decimals. So as you can see, I have plotted my modulus x minus a, which was given to me in the question, along with the line 2x minus a. Line is in the green color and the modulus graph is in the red color. I know that for any values of x that is greater than 2a by 3, my line will always be greater than the modulus. So let me demonstrate that with the help of the graph over here. Let me choose a value of a is equal to, let's say, 3. I know that a has to be positive. So when my a is equal to 3, what will be my x? My x was equal to what? 2a by 3. So that is 6 by 3, which is 2. So it means that anything that is going to be x greater than 2, my line will always give me a higher y value as compared to my modulus. So I can clearly see that over here, when my x value is equal to 2, at that point, both the y's are same, but greater than 2. At greater than 2, I can see that my line graph is always giving me higher y values for the same x values on the modulus graphs. You can see that my modulus graph is always below the line graph. That is what I was looking forward to. You can change my a value, anything that you want in the positive direction, whatever it is. And I know that because my graph was steeper for the line, it is never going to intersect with my modulus, no matter whatever is a positive value of a. That's its 18.9. So what is 2 times 18.9 divided by 3? 2a by 3. It is 12.6. So if I just point the value, you can see that x value is 12.6. Anything greater than 12.6, we know that the line is always going to be greater than the modulus curve.